Okay, good evening. So, last day we discussed the block diagram reduction techniques as well as comparison between open loop and closed loop systems. Audible, na? Is it audible? Okay, thank you. Right. So today we'll solve some problems. So what we discussed, whenever blocks are series means producted, parallel means added, loop means G by 1 plus negative feedback means 1 plus GH, and equivalent diagrams. In equivalent diagrams, main principle is what? In equivalent diagram, the main principle is before shifting whatever the output you are getting, after shifting also we should get the same output. That is the conclusion. Now we'll take one problem, we'll solve it. Okay. Note on the problem. Find the transfer function. Find the overall transfer function. Find the transfer function to the given block diagram. Find the transfer function to the given block diagram. Okay. Draw it. Come on, solve it. Find the transfer function. All are directly given. Directly parallel combination is there. Directly loop combination is there. Directly series combination is there. So come on, get the answer. Solve it, all of you. Homework problem solved. Huh? The answer for homework problem is I think S square. First one is with respect to K, you will get S square plus 3S by S square plus 3S plus 12. S square plus 3S plus 12. Homework problem answer this is. This is with respect to K. With respect to P is minus 3s by same thing denominator. S square plus 3s plus 12. Okay. I hope you did it. Are you solved the volume 1 questions? Volume 1, chapter 1 questions. Are you solved? Volume 1 questions. Volume 1, chapter 1 questions solved. Okay. We'll discuss it at the end. We'll discuss. Okay. At the end, we'll try to discuss it. Okay. Right. Find the transfer function. So come on, get the answer. First, simplify parallel combination. First, simplify parallel combination. This 3 parallel, na? This 3 parallel. What I will get here? 1 plus G3 plus G4. This 3 parallel, na? Parallel means this is 1. No block gain means 1. 1 plus G3 plus G4. So this is a loop, na? It is a loop. So simplify the loop. How to simplify the loop? Listen, loop simplification, very important. Listen, all of you. Loop simplification. So G2 by forward path again G2. So to the feedback path H2, this is the feedback path. To the feedback path H2, forward path gain is G2. So G2 by forward path gain G2. So G2 by 1 opposite sign of the feed. Simple logic of simplification of loop. Simple logic of simplification of loop is to the H2 forward path gain G2. So G2 by no term in the denominator means you write the 1. No term in the denominator means you write 1. Take opposite sign of the feedback. Take just opposite sign of the feedback. Minus means plus. Take opposite sign of the feedback. Minus means plus. Numerator term as it is write in the denominator. Numerator term as it is write in the denominator. Numerator as it is write in the denominator. So that is G2. And numerator term as it is write in the denominator. Product with feedback gain. Product with feedback gain. That is H2. Wherever loop comes, simple logic. To the feedback path, what is the forward path you observe? That is G2. G2 by. No term in the denominator means 1. Opposite sign of the feedback. Opposite sign. Minus means plus. Numerator term as it is right in the denominator. Numerator term as it is right in the denominator. As it is G2. Product with feedback gain. Numerator term as it is right in the denominator. Product with feedback gain. Automatically will get the loop simplification. Automatically will get the loop simplification. Will get the loop simplification. Okay, na? I hope you understood. So, for example, see here. For example, listen. Now, these 3 are in series. G1, this loop, this, all these 3 are in series. Series means producted. Now, I'll write the transfer function. C of S by R of S equal to, I'll write the transfer function. G1, series na, here G2 by 1 plus G2 H2 into 1 plus G3 plus G4. 1 plus G3 plus G4. This is the just product of all the series blocks. G1 into G2 by 1 plus G2H2 into 1 plus G3 plus G4. Now all these three blocks, obvious with H1 tell. G1, this block, obvious with H1. Obvious with H1 feedback. So feedback means what I told, whenever feedback you will get, you follow this. Whenever you see the feedback, you follow this. So it is a feedback for all these three blocks. So that's why simply what you do, just to take opposite sign of the feedback. What is the opposite sign of the feedback? Tell. Plus. Minus means here plus. Actually what you have to do, this total you have to consider as G divided by 1 plus this total G into H we have to write. How we used to solve general procedure? G1, G2 into 1 plus G3 plus G4 divided by 1 plus G2 H2 is considered as G. This is considered as G. This total G divided by again what? 1 plus this total G into H1 we used to write. Again we have to simplify this. But instead of this, what I want to say, instead of doing like this and wasting the time, the simple logic is just opposite sign of the feedback. Even simplify, same answer you will get. Opposite sign of the feedback. Numerator term as it is, you write in the denominator. Numerator term, whatever the numerator is there, this numerator as it is, you write in the denominator. As it is, you write in the denominator. So that means what I will get? G1, G2 into 1 plus G3 plus G4. G1, G2 into 1 plus G3 plus G4. Numerator as it is, we written in the denominator. Product with feedback gain. What is the feedback gain? H1. Product with feedback gain. H1. That's all. It is the answer. This is the answer. Simply wherever loop comes, take opposite sign of the feedback. Numerator as it is in the denominator. Product with feedback gain. Okay na? Okay. I hope you understood. Got it? Tachometer not in syllabus actually. Tachometer is a PD current. Tachometer is a derivative controller, that is KS. Transfer function for the tachometer. It will come in the PID controllers. Okay. Okay. Some students are solved. Some students are not solved. Volume 1, volume 2. University exams are going on. Okay. At least try volume 1. At least to solve it by tomorrow. Who are not solved, solve by tomorrow. At least volume 1, volume 2. Who are solved only volume 1, by tomorrow solve volume 2. Both I will discuss tomorrow. If you have any doubt, we'll see. Okay. Try. Or at least today I'll discuss volume. I'll see based on time. Next. So next question. Okay, completed. Next question. Get the screenshot otherwise. Next question. Same, find the transfer function. Find the transfer function. Find the transfer function. Find the transfer function. Come on, solve it. All of you, this one also. 1 minute, I'll draw it. G1 H1 G2. I'll take here positive feedback. H2 G3 H3 G4 Come on, do it. Come on, find the transfer function. Try karo. Change. Do it. Akshay Kumar.
Sir, actually, I have doubt in volume 2.
That we'll discuss later. Now, volume 1, volume 2 will discuss it.
Okay.
At the end we'll discuss, or tomorrow we'll discuss. Okay.
Yeah. Okay. Yeah. Thank you, sir.
Right. Come on, write the answer. All of you. Find the transfer function, all of you. Write the answer, all of you. Yeah, tomorrow I'll discuss. Most of the students, they are asking discuss tomorrow. Lakshminath. Lakshminath Nani. Okay. Right. Anybody answer? Yes, very good. G1, G2, G3, G4. Very good. Some students are written answer correctly. Very good. Listen here. Listen. All of you listen. See. First simplify. First C of S by R of S equal to C of S by R of S equal to. First simplify the first loop. What is the first loop? This G1 H1. First G1 H1. Direct loop, na G1 H1 is direct loop. First simplify G1 and H1. So if you simplify G1 and H1, what I will get? Tell to the H1, to the feedback path H1, forward path is G1. To the feedback path H1, forward path is G1. So G1 divided by no term in the denominator means 1. No term in the denominator means 1. Take opposite sign of the feedback. Take opposite sign of the feedback. Opposite sign of the feedback. Minus means here plus. Opposite sign of the feedback. Minus means plus. Numerator term as it is right in the denominator. Numerator term as it is right in the denominator. That means G1. Then product with feedback gain. What is the feedback gain? Tell H1 as it is H1. That's all. It will become a loop simplification. It will become a first loop simplification. Next again, this loop having a series with G2. This loop having a series with G2. This is series with G2. That means what happened? It is product with G2. It product with G2. Now, what happened next? This G1, H1, G2, both are having a loop with what? H2. Again, it is loop with what? H2. It is a loop with H2. Loop with H2. That means what you have to do again? Opposite sign of the feedback. What is the feedback? Because it is a loop, now H2 is a loop. Opposite sign of the feedback. Plus means minus. So here minus. Then numerator term. At the instant, what is the numerator? G1, G2. Numerator term as it is in the denominator. Numerator term as it is in the denominator. So opposite sign of the feedback means here minus. Minus. Numerator term as it is in the denominator. So G1, G2. Numerator term as it is in the denominator. G1, G2. And product with the feedback gain. What is the feedback gain? H2. So simply write H2. So product with feedback gain. That means simply H2. Okay, na? Opposite sign of the feedback minus numerator term as it is. Numerator as it is right in the denominator. Product with H2. Product with feedback gain. Now what happened? We simplified this up to H2. Now this is in series with what? G3. It is series with G3. That means what you have to do? Product with G3. Product with G3. But including G3, so all this G1, H1, G2, H2, G3, we are having a feedback with H3 like this. We are having a feedback with what? Like this, H3. We are having a feedback with H3. So that means what we can do? Opposite sign of the feedback. Opposite sign means here minus means here what happened? Plus. Minus means here plus. Minus means plus. Numerator term as it is right in the denominator. What is the numerator term? G1, G2, G3 as it is right in the denominator. Numerator as it is right in the denominator. That means what I will get? G1, G2, G3. Numerator as it is right in the denominator. As it is right in the denominator. Product with feedback gain. What is the feedback gain? H3. Feedback gain is H3. feedback gain is H3. Again, all these blocks having series with G4. This block series with G4. That means here G4. So series with G4. So G4. So G4. Then what happened? Again, it is having a unity feedback. All these blocks having a what? Unity negative feedback like this. Unity negative feedback like this. Unity negative feedback. Unity negative means what happened here? Negative. Negative means opposite sign. Opposite sign means here it become plus. Numerator term as it is you have to write in the denominator. Numerator term as it is you write in the denominator. So that means what it is? G1, G2, G3, G4. Numerator as it is in the denominator. Product with feedback gain. What is the feedback gain? 1. That's all. Product with feedback gain. That is 1. That's all. Okay, na? I hope you got it. Many students are written answer correctly. Good. Okay, like this you have to solve. You practice in your home. Wherever loop comes to the feedback path, what is the forward path you observe? First loop forward path G1. G1 will be there. Opposite sign. So numerator as H1. Second feedback path, what is the forward path? G1, G2. Automatically that G1, G2 will come here. Third feedback path, what is the forward path? G1, G2, G3. Automatically it will come. So follow this so that directly we can write the what? Loop simplification. But whatever it is, if objective bit ask na, find the transfer function, then what we'll do, we'll simply follow the signal flow graph analysis. If in case block diagram able to simplify directly without simplification, without shifting operation, if you are able to write directly, then we can use the block diagram technique and then we can get the transfer function. In case shifting operation is required, then you better get the transfer function by using signal flow graph analysis. Because signal flow graph analysis, directly we can write the transfer function. So in signal flow graph analysis, we can write the transfer function directly. Transfer functions can write directly in signal flow graph analysis. Take na, practice it so that it'll become perfect. Take na. Next one. Next problem. Next problem. I hope completed na? I hope completed. I'll get the screenshot. Next problem. Right. Draw the equivalent block diagram to the given block diagram. Draw the equivalent block diagram. Draw the equivalent block diagram. Equivalent block diagram to the given system. To the given, you can say block diagram, whatever it is. Or put it R, what is there? You also draw it and solve before me. Now what you have to do? Shift this summing point ahead of G2 and draw the equivalent block diagram. Shift the summing point ahead of G2 and draw the equivalent block diagram. Come on, try karo. Try karo. Tell the answer. Do it. You try. We can solve by SFG also, but practice. Not equivalent transfer function. You draw the equivalent block diagram. Equivalent diagram you have to draw. After shifting, what is the equivalent diagram? Equivalent block diagram you have to draw. Try karo, all of you. Completed. Okay, I'll draw it. Listen, all of you listen. First of all, which blocks are affected? Tell. What are the blocks are affected here? Which blocks are affected? Anybody? G3, G2, G3, G3 and H. Yes, good. So here, listen, it is very, very important. It is very, very important because equivalent diagrams many students used to mug up in the BTech. You listen, no need to mug up. So easily we can draw the equivalent block diagrams. Listen, all of you. So simple logic is, which blocks are affected means while doing the shifting operation, listen all of you, while doing the shifting operation, never change the any block gain along the straight forward path or main forward path. See, along the main forward path, this is the main forward path. So never change any block gain along the main forward path. Main forward path means straight. From input to output, whatever the path is there, that is called main forward path. Okay, na? Never change any block gain along the main forward path. While doing the shifting operation, never change any block gain along the main forward path. Main forward path means along the path we are doing the shifting operation. Na? Along this path only, year to year means along this path we are doing the shifting operation. So along this path, no block gain changes. Along this path, no block gain changes. Means G1, G2, G4, G5 not changes. What are the blocks changes means? The change occurs in only additional forward paths and feedback paths connected to that particular point only. To this point, what is connected? Tell. G3 connected, H connected. So there is a change in G3 and H. There is a change in G3 and H only. To this point, to this summing point, what are connected? G3 is connected, H is connected. That means while doing the shifting operation, the changes are occurs in additional forward path and feedback paths only. Never change any block gain along the main forward path. Main forward path means the path along which shifting operation performed. The path along which shifting operation is performed. For example, I will shift this take-up point. For example, I will shift this take-up point. If I shift this take-up point from here to here, which block gain affected? To this, what is connected? Don't change anything. I am changing from here to, I am changing from here to where here we are changing. For example, I am shifting. So I am shifting after G5 to adopt G5. So to this, what is connected? Don't change anything along the main forward path. We are shifting from here to here. This is the main forward path. That means changes occurs in only H. To this point connected only H. That means change occurs only H. To this summing point G3H connected. That's why both are changes. For example, I'll shift this. Which block gain affected? Only G3, because to this connected only G3. Okay, to this connected only G3. So what is the conclusion? While doing the shifting operation, 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 changes occurs only in additional forward path, only in additional forward path and feedback paths connected to that particular point only. Feedback paths connected to that particular point only. Never change any block gain along main forward path, Never change any block gain along main forward path. Don't change any block gain along main forward path. Okay. So now what happened? To this summing point, to this point connected G3 and H. So G3 and H changes. Now before shifting, what you do? We identified that there is a change in G3 and H. G3 is a forward path. So you write a forward path gain from input to output. Before shifting. First we'll go by procedure. After that I'll tell shortcut. First you write the forward path gain from input to output. Forward path gain you write from input to output. What is the forward path gain? Tell. You'll remove the R, no problem. The R is common, remove it. So that means what is there? G3, G4, G5. G3, G4, G5. So because it is a G3 is forward path, you have to write forward path gain. H is a feedback path. H is a feedback path like this. So then you have to write the loop gain. If it is a feedback path, you have to write the loop gain. So this loop gain you have to write. You have to write the loop gain. Loop gain means just to product the gains along the path. Loop gain means just to product the blocks along the path. Product the blocks. So that is G4, G5, H. Just product it. G4, G5, H. Just to product the blocks along the path. Just to product the blocks G4, G5, H along the path. Just to product it. Just to product the blocks along the path. That's all. Now draw the equivalent diagram. Next we'll draw the equivalent diagram. Equivalent diagram. After shifting, I'll draw it. So now here R. Now here G1. Here G2. Here summing. Here G4. Here G5. C of S. Main forward path not changes. What is the main forward path? Tell here G1, G2, G4, G5. Here also what is the main forward path? G1, G2, G4, G5. Main forward path never changes either here or here. Before shifting also, after shifting also, main forward path gain is same. Now what happened? Sorry, we shifted here. Na? So now summing point here. We shifted to here. Na? Here summing point. Here G2. Now also what is the path gain? Tell G1, G2, G3, G1, G2, G4, G5. Here also what is the path gain? G1, G2, G4, G5. So path gain means just to product the gains along the path, irrespective of summing and take up point. Irrespective of summing and take up. Just to product the gains along the path. G1, G2, G4, G5. Just to product it. That's all. Okay, na? Now I'll draw the G3. Here G3 is there. This block gain is affected. So then what you will get, we'll discuss. So actually here what is there? G3 is there. Plus. Next here H is there. So here to here H. Now we'll draw an equivalent diagram. Like this, we draw the equivalent diagram. Now again, you write the forward path gain. After shifting also, draw the forward path gain. What is the forward path gain? Tell here. This forward path gain, you draw it. What is the forward path gain? Tell, come on. Input to output. Same through G3 only, I would write the forward path gain. What you are getting? Tell. G3, G2, G4, G5. G3, G3, G2, G4, G5. But what do you want? G3, G4. Before shifting, after shifting, it should be same. Before shifting, after shifting, it should be same. Before shifting, what you are getting? G3, G4, G5. G3, G4, G5 only we want. What is the extra we got? G2. That means that G2 should get cancelled. G2 extra you got, that G2 should get cancelled. That means I require to G3 divided by G2 so that G2 cancel. That means here G3 by G2. Before shifting, after shifting, it should be same. Before shifting what? So G3, G4, G5. After shifting also G3 by G2, G2 cancel so that G3, G4, G5. Before shifting, after shifting, it is same. That's all. So first shift the summing point or take up point. After shifting, again you write the path gain. It should be same. Then you will get the idea either divided or producted. Even this path gain also, loop gain also you write it. Come on, what is the loop gain? What is the loop gain? Tell. What is the loop gain here? Come on, after shifting, what is the loop gain? You got it. So G2, G4, G5 and H. G2, G4, G5, H. But what is required? What is required? G4, G5H only. G4, G5H only. But what is extra you got? G2. That means that should get the cancel. So that should get the cancel. That means divided by G2. So that G2 cancel. That means H by G2. Now before shifting, after shifting. Before shifting G4, G5H. After shifting also G4, G5H. G2 is getting cancel. Like this, you have to find what? Equivalent block diagram. Before shifting, after shifting, the path gain should be same. The path gain should be same. So like this, you have to identify the equivalent block diagram. Equivalent block diagram. Okay, na? I hope you understood. You practice so that you will get it again. You practice it, will get it again. Okay, na? Okay, next. So this is by the procedure, but simple logic I'll tell. Listen, all of you. You listen, get the screenshot you want it. You want it, get the screenshot. Otherwise, they'll send it PDF. Next, listen. Okay. Listen. I'll explain same thing. Listen. How to identify directly. G1. G2. G4. G5. C of yes. Right. So listen here. First, you have to identify which blocks are affected. We identified that there is effect in only G3 and H. Affected blocks we identified. What are that? G3 and H. First, you have to identify affected blocks. Now, first I'll discuss about G3. Then after that, we'll discuss about H. G3. To G3, just once scan how many blocks are there through G3. To G3, through G3, how many blocks are there? Just to scan it. 1, 2, 3. G3, G4, H. Just scan it. You scan it. G3, G4, H. Now we are going to shift here. Now wherever you shift it, the main forward path, you shift here or here or here. Wherever you place it, the main forward path gains are not affected. The main forward path gains are not affected. You shift it either here or here, or you put it here in summing point, even here. What is the path gain? Main forward path gain? G1, G2, G4, G5. This not changes. Change in only G3 and H. Now, this summing point, before shifting, count the number of blocks. G3, G4, H. Now, I'll shift this to here. Now, I'll shift to 1 minute. Now, I'll shift. Now, I'll shift to here. So, once I shift here, what happened? You tell. What happened? Before here it is there. Now, I'll shift to here. Then now count the number of blocks. How many blocks are there through G3? Count it. 1, 2, 3, 4. Previously 3. Now 4. Which block extra? G2 is extra. Now G2 extra. That means if any block gain extra along the path, extra block gain along the path along the path, then it should be divided. Then divide with the block gain. Then divide with the block gain. With that block gain. Divide with that block gain. Whatever the extra block gain is, that should be divided. Any block gain missing or losing block gain. In case losing block gain along the path, then product with that block gain, then product or multiply with that block gain, product with that block gain. For example, before we are having here, so before shifting, what happened? Before shifting, we are having 3 block gains, G3, G4, G5. Once I shift here, along the block gain out of there, along the path gain, 1 block gain extra, G3, G2, G4, 1 block gain extra. That should be divided. That means divided by G2. In case I'll shift here, then what happened? Tell. So what happened? How many block gains extra along the path now? G3 and G1, G2, G4, previously 3 only. Now how many? 1, 2, 3, 4, 5. 2 block gains extra. What are that? G1, G2 is extra. That means we require to divide with what? G1, G2. We require to divide with G1, G2. Just before shifting. After shifting, you count the block gain. That's all. Before shifting, after shifting, you count the block gain. So yeah, whatever the block gains extra, that should be divided. For example, here see, come to this H. Before shifting, how many blocks are there? 1, 2, 3. G4, G5, H. 3 blocks are there. Now, I'll shift this block gain to, for example, this point to here, I'll shift it. What happened? How many blocks? G5 and H. Actually, G4, G5, H. Now, what are there? G5 and H. That means what? 1 block gain missing. What is that missing? G4. So, G4 should be producted. For example, I'll shift to here. For example, this point, I'll shift to here. What happened? Before shifting, 3 block gains. Before shifting, G4, G5, H. After shifting, only H is there. That means we are missing what? G4 and G5. That means we should product G4 and G5. So like this, you have to do the analysis. So before shifting, how many blocks are there? After shifting, how many blocks are there? So before shifting, after shifting, it should have same number of the blocks. So before shifting, for example, see here, 1, 2, 3. After shifting, dekho, only 1. That means 2 blocks missing. The 2 blocks I producted here. Like this, you have to do it. So simple logic, before shifting, after shifting, that path gain should be same, or number of block gains should be same. Okay. I hope you got it. You practice so that it will clear. Okay. After going home one more time, you solve this problem so that it will be cleared. Okay, na? Next. But when just for idea sake, I am discussing in the GATE exam or IES exam for objective type, never do the shifting operation. Because it is time consuming and you have to draw the equivalent block diagrams. Another drawback is you have to draw the equivalent diagrams. So it will take the time. But you should know, that's why I'm discussing. So the easy method, signal flow graph analysis, that we'll discuss after completion of this. Still another 3-4 problems we'll solve in the block diagrams. So we'll practice more number of problems. Even block diagram problems also we'll practice in the signal flow graph. Okay. Next problem. Get the completed. Okay. Right. Next. Find the transfer function. To the given block diagram. Come on, find the transfer function. Find the transfer function. Do it, all of you. Come on, do it. First, always simplify the direct blocks. In the block diagram reduction techniques, first step always order of priority is very important. Order of priority is very important. So first always you have to simplify series. First step one, series blocks, if it is available. Next parallel, next loop combinations. If it is available directly, you have to simplify this series, parallel and loop. If it is not available, next you have to go for shifting the summing points. Any two summing points are adjacently placed. You have to shift these two summing points such that we should get any one of these three combinations. Any one of series, parallel and loop. In case summing points not placed adjacently, in case, even though shifting these summing points, we are not getting any combination of series and parallel and loop combination, then better not to disturb the summing points. If there is no advantage, better not to shift the summing points. If this second condition not there in case, then you have to shift the block gains and take up points. You have to shift the block gains with take up points. You have to shift the block gain with take up points such that either after the block gain or before, such that you should get the any one of combination of series, parallel and loop. Even shifting take off and block gain not possible. Next you have to go for block gain with summing points. You have to go block gain with summing points. Block gain with summing points. So we have to shift this block gain with the summing points such that you should get any one of series, parallel and loop combinations. You should not go directly to the what? Summing and block gain. First priority summing. Next second priority block gain takeoff. Next third priority block gain and summing. The last priority in the shifting operation, summing and take-up points. Never interchange summing and take-up points unless until it is compulsory. Unless until it is compulsory, then only have to interchange the summing and take-up point. It is the last priority in the shifting operation. In the shifting operation, last priority is interchanging summing and take-up point. Because if interchange summing and take-up point, additional summing point is created. Additional summing point is created. Additional summing point is created. So that's why it is the last priority. So, but for objective types, it is not required, but just for idea's sake, I discussed. So here what happened? Directly we are having a loop combination. First simplify direct loop combinations. If you simplify direct loop combination, this is the direct loop. This is the direct loop. You simplify this. What you will get if you simplify this? Tell. If you simplify this, what I will get? G4 by 1 opposite sign of the feedback plus numerator term as it is G4 product with feedback gain H2. So this is a simplification of loop. This is a simplification of the loop. That means what I can draw here, if I draw the diagram here, what I can do? Okay, I'll draw it. R of S, summing point, G1, plus G2 G3 summing point. Here what I can write directly? G4 by 1 plus G4H2. C of S. Here G5. Here H2. Right, this is the diagram. Now, we cannot simplify unless until you shift from one point to another point. So, we cannot simplify here. It is not possible to simplify. Can you simplify here? It is not possible without shifting operation. So, we have to shift it. We require to shift from the take-up points. Which point you have to shift? For example, here, listen, one more logic here. Some people, if you give any block diagram, so if you ask get the transfer function, they'll go on look it. They'll think automatically adjusted. It is not adjusted automatically. So what you have to do? You should have a logic of simplification. You should know logic, how to simplify. You try to make the blocks are parallel. Main logic is here. You try to make the blocks are parallel. You try to make the blocks are parallel or loop combination. Which blocks I can make it parallel? Which blocks I can make it loop? Just you think it. Which blocks I can make it parallel? Which blocks I can make it loop? If I look this diagram, I got the idea that I can make G3 and G5 parallel. I can make G3 and G5 parallel. Yes or no? Yes or no? So if I remove this, what happened? Tell G3 and G5 is parallel. Or I can make G2, G3, H2 is a loop. I can make, if I remove this, what happened? Tell G2, G3 series and H2 loop. So that means just you should have an idea, or you should think it, which blocks I can make it parallel, which blocks I can make it loop. Just to think it. So automatically you will get the answer. So I want to make it, for example, G2, G3, H2 is a loop. Then what you have to do? This point we have to shift. Where you will shift? Ahead of G2 or after G3? Where you will shift? Ahead of G2, that means there are two possibilities. This point can be shifted here or we can shift it here. Not 1,000 possibilities. We are having two possibilities. Where you will shift? After or ahead? Simple logic, you know. Simple logic, you know. Say take a point, shift to, this is a take up point. This is take up point. This is called summing point. Take a point, shift to, this is also take up point. Take a point, shift towards the take up point. Summing point, shift towards the summing point. Take off should be shifted towards the take off only. Summing should be shifted towards summing only. Take off should be shifted only towards take up point. Summing point should be shifted towards summing point. Then the problem becomes very easy. The simplification becomes very easy. That means what happened? This take up point should be shifted towards this take up point. So take up point, this is the take up point, take up point. So shift towards the take up point. Then the problem becomes very easy. So take up point, shift towards the take up point only. Which block gain affected here? G5 is affected. The affected block gain is G5. G5 is affected. So before shifting, how many blocks tell? G1, G2, G5 and G4 means 1, 2, 3, 4. 4 blocks. In case now I will shift to after G3, for example, like this. Now count the number of blocks through G5 from input to output. How many blocks? 1, 2, 3, 4, 5. Previously, how many got it? 4 only. Previously, check it. 1, 2, 3, 4 only. Now, how many? 1, 2, 3, 4, 5. Which block extra? Check it. This yellow mark is not there for G3. G3 extra. That means G5 by G3. The equivalent block gain here, it will become what? G5 by G3, like this. G5 by G3. Now, this will become a loop. This 1 in 1 as well as G5 by G3 become a what? Parallel. This 1, this is 1. No block gain means 1. 1 G5 by G3 is a parallel. Then this loop can be simplified. 1 G5 by G3 simplified. Then all R will become series. Then we'll get the answer. This is one method. This is by making G2, G3, H2 is a loop. By making G2, G3, H2 is a loop. But I don't want to, for example, I don't want to loop. I want a parallel combination. This is one way. This is one method. This is one method. What is this block gain? G5 by G3. Now what happened? Now simplify this, get the answer. If we simplify, what I will get? Tell what I will get. This is a loop. This is a loop. This is a parallel. What is the answer for this loop? Get the answer for loop. Come on. Get the answer for this loop. What you will get? Tell. G2 by G2, G3 by 1 plus G2, G3, H2. And what is this simplification? 1 plus G5 by G3. Yes, sir. Now all are in series. All are in series. Come on. All are in series. So all are in series means product it. You product. Come on, you product it. You product what you will get. Come on, do it. G1 C of S by R of S equal to product it. G1, G2, G3, G1, G2, G3 divided by 1 plus G2, G3, G2, G3, H2. H2 na? H2. Then again, what happened? Series with what? This block na? What is this block? G3 plus G5 by G3. Now product this, you product this. So product it, that means G3 plus G5 by G3. Series na, product it. G3 plus G5 by G3. Okay, series blocks you simplify first. Next, series blocks, or you write it divide also, nothing wrong. You write like this also. You can write G3 plus G5 by G3. Next. Next bolo. Series with this na. Series with what? G4 by 1 plus G4 H2. This is the what? Simplification of series in blocks. This is the simplification of all the series in block. Series in block, this series. All this series in blocks. All this series. All these blocks. So now what you will get? G3 cancelled. Then write the overall transfer function. What is the overall transfer function? Tell? C of S by R of S equal to G1, G2 into G3 plus G5 into G4 divided by 1 plus G2, G3, H2 into 1 plus G4, H2. Yes or no? Yes or no? Yes. Next, all these blocks having a unity negative feedback. All these blocks having a unity negative feedback. Negative feedback. Negative means opposite sign, means plus. Numerator term as it is right in the denominator. Numerator as it is right in the denominator, product with feedback gain. That means what I will get? G1, G2 into G3 plus G5 into G4. That's all. Numerator term as it is in the denominator. Product with feedback gain. What is the feedback gain? 1. Feedback gain is 1. So this is the answer. This is the answer. This is one method. What is this method? This is method 1. This is method 1. What is the method 1? By making the blocks are loop combination. We make the blocks in a loop combination. We make what we did? G2, G3, H2 as a loop. So we want a loop, then we adjusted remain things. To make G2, G3, H2 as a loop, we adjusted remain things. We adjusted the takeoff point. Now I want to make it parallel. G3, G5 as a parallel. Come on, solve it. I want to make, come on. I want to make this G3, G5 parallel. Come on, do it. Come on. Make it parallel. Make it parallel. I'll copy this. File gone. How to get it back? 1 minute. That file somewhere it gone. How to get it back, man? Is it saved anywhere? Is it saved anywhere? Previous slides. 1 minute. No audible, na? Audible, na? That problem, the slides are gone due to some mistake. Is it stored anywhere? 1 minute. I'll check it. Do you want to change this? Okay, slides are gone. Actually, what we discussed. So no problem. Same problem I'll discuss. Okay. Same problem. The second method I'll discuss. I'll draw the diagram. R of S, summing point, G1, summing point, G2, can I get it blocked that? Can I get it back that slides which are eliminated, which are deleted? Is it possible? Anybody having idea? The slides which are deleted, cannot be back now. Control Z already I tried. I save all. I didn't save. That is the problem. In the recorded session, yes, correct. I think in the recorded session it will be there. 1 minute. First, I'll explain this. After that, we'll take the break. I'll talk with that recorded. G1, G2, G3. Here summing. G4. C of S. So here G5 plus next here take a point H2 minus minus. Okay. So now listen. So I want to make it parallel combination. This two I want to make it parallel. Previously we make it loop now I want to make it parallel. So here G4 by 1 plus G4 H1 I think. Here this already we simplified. G4 by 1 plus G4 H1. Now I want to make it parallel. Here I want to make it parallel. So parallel means what is the problem? This take up point is problem. Shift this take up point end of G3 because take up point should move towards the take up point only. Never interchange take up point and summing point. Never interchange take up point and summing point. Take up point and summing point. Never interchange take up point and summing point. Take up and summing point. So now what happened? So before which block gain affected? H2 is affected because to this point connected only H2. So H2 affected. So H2 is affected. Before shifting how many blocks? Count it 1, 2, 3. 1, 2, 3. Before shifting 1, 2, 3. 1, 2, 3. After shifting, for example, if I shift here, after shifting how many blocks are there? 1 and 2. 1 and 2 only is there after shifting. 1 and 2. Before shifting, 3 blocks are there. G2, G3, H2. After shifting G2, H2. What is missing? G3. So I need to product G3. I need to product G3. I need to product G3. Okay. I need to product with G3. Now these two are parallel. Now these two parallel. This two is a loop. So that means one problem can be solved by many ways. One problem can be solved by many ways. One problem solved by many ways. So now this two is a what? This two is parallel. So G3 plus G5 is parallel. Now this is what? A loop. So that means what I will get? G2 by 1 plus G3 H2. G3 H2. G2 by 1 plus G3 H2. Now simplify, all these are series. Then what is the answer? C of S by R of S equal to what I am getting? G1, G2, G3 plus G5 into G4 divided by 1 plus G3H2 into, again this block gain, 1 plus G4H1. Again, all these blocks are unity negative feedback. Minus means plus. Numerator term as it is in the denominator. Numerator term as it is in the denominator. That means G1, G2 into G3 plus G4, G3 plus G5 into G4. Opposite sign of the feedback plus numerator as it is, product with unity. This is the answer. Same answer we got now. The answer is same. So before now, the answer is same. So here in the block diagrams, first you have to make it blocks are parallel or blocks are loop. Then you will get the answer. Blocks may be parallel, blocks may be loop. Okay, na? Next. One more problem. Or we'll take break. Time is 35. Okay, take the break or 10 minutes break. This only take the 10 minutes break. So I'll talk with that fellow. Okay. Take the 10 minutes break. After that, I'll continue. Okay. One. Okay. Slide outline new slide. Okay, next problem. Why this? Right? Okay. Okay. Right. Next problem. Find the transfer function. Find the transfer function to the given block diagram. Find the transfer function to the given block diagram. Solve this problem. R of S summing point G1 summing point G2 C of S minus here H1 minus H2 G3 plus, come on, solve it. Find the transfer function. Find the transfer function. Find the transfer function. First simplify this. First simplify this. First simplify loop combination. So G2 by 1 plus G2H2. Next, you think it. Once you simplify this, next what you have to do? You think it. R of S, summing point G1, again summing point, here G2 by 1 plus G2H2, C of S. Next here H1, next year G3. Plus. Now we want parallel or loop. What do you want here? Parallel or loop? You want parallel or loop here? Is it audible? Is screen visible? Is it audible? Okay. So with this link, get it back. Huh? Somebody send the link. HTTP forum, Autodesk, Sketchbook, forum, recovering an unsaved file. Okay, I'll check it. Come on, get the answer. So what do you want here? We'll make it parallel G3, G1, or we'll make it to loop. So make it parallel, for example. Loop you try. For example, make it parallel. G3, G1 parallel. Then what is the problem? Tell. What is the problem? The summing point is problem. We have to eliminate this summing point. Eliminate this summing point. For example, eliminate this. Eliminate the summing point. For example, eliminate this summing point. You eliminate this. Where you have to shift? Interchanging summing and takeoff is a last priority. Interchanging summing takeoff is a last priority. Then where you have to shift this summing point? Your summing point should shift towards summing point, means near to, after the G1 is nothing but after the summing point. You have to shift summing point ahead of G1 is nothing but ahead of summing point, because any two summing points are adjacently placed. Blindly we can interchange the summing point. So any two summing points are adjacently placed, we can interchange it. Still the output which block gain affected? H1 affected. Total how many blocks are there here? 1, 1, 2, 3. 1, 2, 3. So 1, 2, 3. So 3 blocks are there. In case I'll shift here, total how many blocks it will become? 2. In case I'll shift here, total how many blocks? 2. Yes or no? Yes or no? For example, see next slide I'll write. Listen. Listen. So what I'll do? So next slide shifted I will draw. So same thing I'll draw it in the next slide. R of S. R of S. Next G1, G3 parallel. G1, G3, both are parallel. Now we shifted to summing point here. Now here G2 by 1 plus G2 H2. Then C of S, here feedback minus H1. Now tell, before shifting 1, 2, 3 blocks. After shifting how many blocks? 1 and 2. What is missing? Tell. What is missing? G1 is missing. That means G1 is multiplied. 1, 2, 3 blocks. After shifting only 2 blocks. Which block is missing? Only G1 is missing, na? Yes or no? G1 is missing. If I shift this point here, which block missing? G1. So G1 should be producted. So G1 should be producted. Now get the transfer function. These two are parallel. That is G1 plus G3. This is a loop. So what I'll get? Loop means G2 by 1 plus G2 H2, opposite sign of the feedback, plus numerator term G2, product with G1 H1. Now both are in series. So C of S by R of S equal to, so what I will get? G2 into G1 plus G3 divided by 1 plus G2 H2 plus G1 G2 H1. G1 G2 H1. So like this, you have to get the answer. Okay, na? Like this, you have to get the answer. So just first step, you have to decide which blocks you have to make it loop, which block you have to make it parallel. For example, you want to make it loop, you can make it loop. Now you have to shift to this summing point. If you want to make it loop, this summing point you have to shift to the head of G1. Head of G1. Okay, na? So two methods. One problem can solved by many methods. Okay? Okay, na? So here I make it what? Parallel. This two parallel. That's why I shifted this summing point to head of G1. The head of G1 is nothing but head of the summing point. Then you draw the equivalent diagram. Then you will get the answer. Okay? Next problem. Got it, na? Any doubt? Sri Charan?
Sir,
Ah,
in the last page,
first page only.
we
Remain
cannot
down.
exchange the two summing points, sir.
Oh, we can exchange, na? Where we exchange? How to exchange?
We can keep that summing point here, G3 summing point in the place of H1
Okay,
summing
I'll
point.
take this is 1 and 2. Now tell which summing point?
First summing points and second summing point we can exchange, no, sir.
How can exchange? In between G1 is there, na?
Okay, okay. Yes,
You
sir.
should not interchange.
Okay, okay.
Okay? Venkatesh? Tell. Tell, man. Hello? Okay, at the end we'll discuss the doubts. Voice not clear. Okay, at the end we'll discuss the doubts. Next question. We'll close this chapter. Next question. Find the gain of the system given below. Find the gain of the system given below. Come on. Find the gain of the system given below. Find the gain of the system. Given below. R of S ten plus plus ten 30 plus come on, find the gain of the system given below. Come on, do it. Solve it. Sri Charan.
So no doubt, sir. Actually, I forgot to lower the hand.
Okay. Venkatesh. Lakshmi Prabha.
Sir, 1F, sir, in that
Hmm.
when we simplify 1F,
Huh?
sir, 1F.
This only.
Okay, method 2, when we simplify, how we are adding with the feedback H2, sir.
Where you are talking? This one.
First page, yes, sir.
This is feedback only, na H2. To the G to H2 is feedback, na loop, na.
Not about this one's the next page, I think. Say, method 2 you said, right, sir, before. Yes, sir, in this. In this, when if we add G1 here, how it will come?
This two parallel, na G1 G3 parallel, na.
Yes, sir.
Added. This two parallel, na added, na. Hello.
Sir, actually, it's not this page, sir. I think the problem previous one, sir. Okay, sir. Slide is previous one, sir.
Previous slide and this only. Now before the class, that is deleted, na.
Yes, sir. That one is deleted one. I think, sir. Okay, sir.
Here not there.
Okay, sir.
Which question that is?
Actually, sir, method 1, method 2, you try.
Okay, we solved. Method 1, you tell what is the problem in method 1?
Not in method 1, sir. In method 2, sir. When we are changing the takeoff point, we are taking with the feedback, right, sir? G3.
Head of G3 will take it. That will become loop and G3, G5 become parallel, na?
Yes, sir.
Parallel, add it. G3 plus G5. And G4 and H2 will become a feedback path. H2, G3 become the feedback path.
Okay, sir. But how we are adding with the feedback G3, you are multiplying with that, right, sir?
Series means product only, na? Series means product. G3 by 1 plus G3 H2 will get it. That will be product with G3 plus G5 by G3, na? Hello?
Okay, sir.
You try, you will get it. Okay, next. What is the answer for this? Anybody? Answer? Anybody? Anybody? Here directly will get the answer because directly I given, no interchanging, nothing. All are parallel series combinations only. Tell the answer. Minus 160, 140 by 91. Minus 7 point. Is it correct? We'll check it. See, listen. First, this 0 means no feedback. So these two are parallel. Both the same direction are parallel. This is 1, this is minus 2 means minus 1. Minus 1 into 10 becomes minus 10. Minus 10. Now these three are parallel. Parallel means what you will get? 10 plus 30. 40. 40 plus here 50. How much? 90. So 90 divided by, this is again loop, na? Feedback path. So 1 opposite sign of feedback plus numerator term 90. That means what you are getting? 90 by 91. Approximately 1. Again, simplify this loop. So how much tell? 12 by 1 opposite sign plus numerator term 12. Product with feedback gain 1 by 4. That means 1 3 ja, 4 3 ja. That means what you are getting? 12 by again 4. 1 plus 3 4. That means again 3 you are getting. 1 into 3 3. So minus 10 plus 3 means answer is minus 7. Approximately minus 7. Exact means you may get it. This is less than 1. Na? I think 7 minus 7 point something you will get. So this is the answer. So like this you have to solve. This total is approximately 1. This total is approximately 1. Okay. Next problem. Next problem. Fine. Completed, na? Get the screenshot. Completed. Next. Next one. Find the output due to multi-inputs. Find the output due to multi-inputs. Find the output due to multi-inputs. Find the outputs due to multi-inputs. Find the output due to multi-inputs. R1 plus G1 plus R2 G2 C of S minus H2 H1. Come on, get it. Find output due to multiple inputs. R1, R2, R3, multiple inputs. Each time you have to consider only one input. Find C due to R1, find C due to R2, find C due to R3. R2, R3 make it 0. R2 0, R3 0. Find C by R1. Just like superposition theorem. Just like superposition theorem. Each time you have to consider only one input. Each time you have to consider only one input. Parallel means both should be same direction. Loop means closed path. Loop parallel, don't get confused. This is a loop. How can you take it parallel? Direction, this is this direction, this is this direction. This is a loop. How can you take it? These two are parallel, this direction, check it. It is a loop. It is not a parallel. Parallel means both should have same direction like this. See, all these three are same direction. Parallel. Next. Come on. If R2, R3 make it 0, then how the diagram? The diagram is R1 summing point, here G1. Now here summing point eliminated, na? R2 0 means, that means here G2. R2 0 means no summing point. This is eliminated. No signal, no, only one signal. Directly we can connect to G2. G2, C, then minus, here H2, and then here H1. This R3 0 and only signal, na H1 direct connected to the H2. So here H1. So this is the answer. This is the diagram. Then find C by R1. C by R1 equal to G1 G2 by 1 plus G1 G2 H1 H2. Then if you write output due to R1, if you write output due to R1, C equal to, we can write even you consider C1. C1 as a output due to R1. C is nothing but C1 plus C2 plus C3. So C1 equal to G1 G2 R1 by 1 plus G1 G2 H1 H2. G1 G2 H1 H2. ठीक है ना? Next. Similarly, write C by C2 by R2. For example, consider output as input as R2. If you consider input as R2, consider output is C2. Then what? R1 can make it 0. Now R1 make it 0. R1 make it 0. Consider as R2. If you consider as R2, how the block diagram tells this is the input, this is the output. This total become feedback path. How the diagram tell? R2 is a input. R2 is a input. Here summing point. Here G2. This is the output. Here H1. Feedback. Here H2. H2. And summing point here eliminated. But negative sign is there, na? That negative sign, see G2, C of S, H1, this R3 0, summing point eliminated, H2. This minus sign you should keep in a block, gain of -1. Minus sign it should keep in a block, gain of -1. Then connected to the summing point. Then connected to the summing point. Then connected to the summing point. The sign of plus. The sign of plus. Come on. Then what you are getting? C by R2. Completed. Then C2. We consider this is C2. C2 by R2 equal to C2 by R2 equal to, come on, forward path gain G2. So G2 by, this total is feedback path 1, opposite sign of the feedback. Here plus means here minus. Plus means minus. Numerator term as it is G2 into feedback path gain. What is the feedback path gain? Minus of H1 H2. Minus of H1 H2. That means what is C2 you will get? G2 R2 by, here G1 is there, na? Here G1 also is there. Here block gain is G1. Here block gain G1. That means what is the feedback path gain tell? Feedback path gain is what? What is the feedback path gain? Minus G1 H1 H2. Minus G1 H1 H2. Minus G1 H1 H2. That means what is the C2? C2 equal to G2 R2 by 1 plus G1 G2 H1 H2. 1 plus G1 G2 H1 H2. Similarly, find C by R3. C3 by R3, for example. Now come on, R3 input. R3 is input. This is the forward path gain. This is the forward path. This is the feedback path. Now R3 is the input. When R3 input, you consider C3 is output. That means here This is R3. R3 is the input. This is the feedback path. Here H1. This is plus. Here this is C of S. Then here H2. H2. Then here -1. Then -1. Here -1. Then here G1. G1. Here R2 also 0. That means here G2. Then C. Now tell what is the forward path again? What is the forward path? Forward path from R3 to, you cannot go like this. You should go only like this. That means the consider here C3. C3 by R3 equal to, what is the forward path again? Minus G1, G2, H2. Minus G1, G2, H2 divided by 1. Opposite sign of feedback means here feedback plus means here minus. Numerator term minus G1, G2, H2 into H1. Then C3 equal to minus G1, G2, H2, R3 divided by 1 plus G1, G2, H1, H2. H1, H2. Okay. So now C equal to C1 plus C2 plus C3. Output C equal to C1 plus C2 plus C3. Output C equal to C1 plus C2 plus C3. That means all these three observed denominator same 1 plus G1, G2, H1, H2 only. 1 plus G1, G2, H1, H2. 1 plus G1, G2, H1, H2. Denominator is same. So that means LCM we can do na. Numerators are added. Numerators are added. So what is the numerator term? First numerator G1, G2, R1. G1, G2, R1 plus G2, R2 minus G1, G2, G1, G2, H2, R3, H2, R3. That's all. So this is the output finally. As the denominator is same, numerators are added. A denominator is same, numerators are added. Okay, na? Like this. Okay. Next problem. Last problem. Find the transfer function. R of S. Find the transfer function. Find the transfer function. R of S. Plus here G plus C of S plus H plus come on, get the answer. Find the transfer function. Where G1 I forget. I written na? Oh, here. Right. Come on. Get the answer. So what happened here? In this block diagram, this take up point 1, this is take up point 2. If you write the output at this take up point 1, take up point 1. You write even take up point output at take up point 2. Take up point 2. The outputs at take up point 1 equal to output at take up point 2. For example, here you are considering x1. Here also signal will be x1 only. So if I write output here, what happened? X1G. Here also X1G. Same signal passes through feedback. Same signal passes through feedback. That means the output at take up point 1 equal to the output at take up point 2. The output at the take up point at the take off point 1 equal to the output at take up point 2. The output at take off point 2. Take up point 2. Hence take up point 1 and 2 interchanged. Hence take off points 1 and 2 are interchanged. As the outputs are same, we can interchange the take up points 1 and 2. If in case outputs, in case here G1, H1, H2, G2 is there, we cannot interchange. Then you have to go for shifting the summing and take up points. That will become more difficult. Instead of that, you can go by signal flow graph analysis. But whenever all the path gains, these are called symmetrical block diagram. Symmetrical block diagram. Above forward path gain, below forward path gain, both are going to be same. So symmetrical block diagram. In that case, we can interchange the take up points. If interchange the take up point, then the diagram becomes like this. This is summing point. This will be G. Here, summing point. Here, summing point. This will be G plus C of S plus H plus H. Then get the answer. What I will get? This will become G by 1 minus GH. This will become G by 1 minus GH. Then C by R equal to both are added na? 2G by 1 minus GH. 2G by 1 minus GH. So with this, I'll close the block diagrams. Then we'll start the signal flow graphs. We'll start the signal flow graphs. Just I'll give the introduction to the signal flow graphs. Okay. Any doubts? Akshay Kumar. Any
Sir,
doubt?
Sir, on 1F, when you have shifted the summing point after the G1,
Ah,
so you multiplied it with the feedback, sir. I didn't got the logic. Like why you multiplied it?
before shifting, how many block gains are there? Before
G1
shifting, if
only.
the summing point here, how many is there? 1, 2, 3.
Yeah.
After shifting, how many is there? 1, 2.
Okay. Yeah.
Which
Yeah.
block gain missing? G1 only, na?
Yeah.
That should be multiplied.
Yeah. And sir, one more at 5F. You
Tell.
yeah, on 5F. You have added -1. So like
Because feedback minus is there, na?
okay.
So that should be included, means you have to add -1.
Yeah. Yeah. I got it. Yeah. Okay.
Okay.
Thank you, sir.
Rajvelu,
Sir, page number 1.
tell.
Sir, you shifted the summing point to after G1 now, sir. Again, you shifted again the second summing point. That is how, sir.
Summing points you can interchange. We can any two summing points adjacently there, we can interchange, because if I place here, again it is not a loop, na? In case I'll place summing point here, is it a loop directly?
No, sir.
That's why again you have to shift to the head of the summing point. Placing summing point here or anywhere, the answer is not changes. That's why any two summing points adjacently is there, blindly we can interchange.
Okay, sir. Thank you, sir.
Okay. Next, we'll start the signal flow graphs. After that, I'll discuss the doubts. Okay. Next, signal flow graphs. Signal flow graphs. Signal flow graphs. Right. What is a signal flow graph? What is the objective of signal flow graph? What is the purpose? Tell. Purpose is to find overall transfer function of the system. To find overall transfer function of the system. To find overall transfer function of the system. To find overall transfer function. The second one is to find the ratio of any two nodes. To find ratio of any two nodes. To find ratio of any two nodes. To find ratio of any two nodes. This is the purpose of signal flow graphs. Block diagram just overall transfer function, but signal flow graph overall transfer function as well as to find the ratio of any two nodes. And one more thing is that block diagram techniques is valid for linear and non-linear systems. Signal flow graph techniques valid for only linear systems. Block diagram techniques are valid for linear and non-linear systems. Linear and non-linear system. But non-linear block diagram different. Linear and non-linear systems, which is not in syllabus, but the techniques valid. In non-linear block diagram is switches will be there in the block diagrams. So block diagram techniques are valid for linear and non-linear systems. Whereas signal flow graph analysis, signal flow graph analysis valid for only linear systems. Valid for only linear systems. Signal flow graph analysis valid for only linear systems. First of all, what is the signal flow graph? What is the definition of SFG? What is the definition? What is the signal flow graph? Signal flow graph is basically, it is a graphical representation of set of linear algebraic equation. Basically what happened, for example, I'll take a simple RLC circuit. For example, I'll take a simple RLC circuit like this. A simple RLC circuit I'll take. Something like this. Something like this, for example. Consider. This is one electrical network. This is one electrical network. So if you want to find overall transfer function, first basically what you have to do, you have to write the KVL equations. You have to write I already told KVL equation, simplification all. If you write KVL equation without applying Laplace, what you will get here? If you consider here current I1, here R, here L1, C1, if I consider, what I will get? VI of S6, VI equal to I1 R1, then L1, yes or no, dI1 by dt plus 1 by C integration I dt, yes or no? That means it consists the integrations as well as differential equations you will get. Integro differential equations you will get. If I write here KVL, so what I will get? IR, L di by dt, 1 by C integration I dt. That means that equations consist integration and differentiation equations. Integro differential equations you will get. How many means that depends on the system. For example, if you take here 1, 2, 3 and 4 equations you will get. 4 integro differential equations you will get. You want to simplify this integro differential equations, it takes a lot of time. First problem is a lot of time it takes. The second one is, if you eliminate integration and convert into differentiation, you will get a higher order differential equations you will get. You will get the higher order differential equations. Higher order differential equations you will get. Higher order differential equations you will get. Differential equation. You want to get the solution, it takes a lot of time. That's why what they are telling, instead of solving this higher order differential equations and spending a lot of time, what they are telling, apply Laplace transform to integral differential equations. You apply Laplace transform. What is the advantage of Laplace transform? The integral differential equations are converted into linear algebraic equations. Linear algebraic equations. Integral differential equations are converted into linear algebraic equations. How many linear algebraic equations you will get? That depends on the system. You will get the set of linear algebraic equations like Vi equal to something, I1 equal to something, V1 like this. You will get the set of linear algebraic equations. You want to get V0 by Vi by solving this linear algebraic equations. For example, we solved it. Z1, Z2, Z3, Z4. It takes a lot of time. If it 3, 4 is there here like this, many components is there, it takes a lot of time. Even use the Cramer's rule also. If the det is 4 by 4 matrix, 5 by 4 matrix, it takes a lot of time. That means instead of going all these mathematical calculations, what they are telling, whatever you are getting this set of linear algebraic equations, you construct the signal flow graph to this. To the set of linear algebraic equations, just you can draw a signal flow graph. Once you draw a signal flow graph to set of linear algebraic equations, then you can find overall transfer function. Then we can find even ratio of any two nodes without any change in the signal flow graph. Without any change in the signal flow graph, we can find the overall transfer function as well as ratio of any two nodes. As well as ratio of any two nodes. ठीक है ना? ठीक है ना? So that means what is a signal flow graph definition? It is a graphical representation of set of linear algebraic equations. Set of linear algebraic equation between input and output. So what is the definition? What is the definition? It is a graphical representation of graphical representation of set of linear algebraic equations. Set of linear algebraic equations between input and output. Between input and output. Another thing, the set of linear algebraic equation represents the system. Set of linear algebraic equation represents the system. Represents the system. Set of linear algebraic equations represents the system. ठीक है ना? So signal flow graph analysis basically developed to avoid the mathematical calculations. Signal flow graph analysis is developed to avoid the mathematical calculations. To avoid the mathematical calculations. Okay. So here basically there are 5 topics are there in the signal flow graphs. The first one is construction of signal flow graph. To linear algebraic equations. The second one is loops. We have to discuss the loops and non-touching loops. The third one is Mason's gain formula and finding transfer function. Fourth one is ratio of any two nodes. The fifth one is construction of SFG to electrical network. So these are the 5 topics we have to discuss. So first to put the heading, construction of signal flow graph to linear algebraic equations. Construction of signal flow graph to linear algebraic equations. Construction of signal flow graph to linear algebraic equations. Take the first equation, y2 equal to 10 times of y1. You draw the signal flow graph to this command. What are these y1, y2, y3, y4 nodes we used to represent in the signal flow graphs? What are the nodes in the signal flow graphs? Nodes in a signal flow graphs are variables. Nodes in the signal flow graphs are variables. Nodes in the signal flow graphs are variables. Nodes in the SFG are variables. Variables means like current, voltages, path gains 10, 20 like that is there na. Path gains are constants. Path gains are constants. Like it is impedance, admittance of the components. Path gains are what means? Impedance or admittance of the components. Impedance or admittance of the components. It may be R, RXL, or 1 by XL, admittance of the component. Admittance of components. Whereas variables means like currents and voltages. Currents and voltages. Now draw a signal flow graph for Y2 equal to Y1. I'll draw in the next page. So Y2 equal to 10 times of Y1. So the variable which lies in the right is called input node. The variable which lies in the right is called input node, sir. The variable which lies in the right is called input nodes. Left is called output nodes. The branch always should be start at input node. End at output node. The path gain is 10. The 10 is called path gain. 10 is called path gain or transmittance. 10 is called path gain or transmittance. It is called path gain or transmittance. 10 is a path gain. Transmittance means path gain only. Now draw the signal flow graph. Y1 is a input node. Y2 is a output node. The direction from always from Y1 to Y2. The direction always from Y1 to Y2. That constant 10 act as a path gain. This Y1 is called source. Y2 is called sink. The signal flow graph and block diagrams are unidirectional. It is arrow represents the direction of the signal. Second problem is solve it. Second problem. Y4 equal to 2Y1 plus 4Y2 plus 6Y3. Come on, draw it. Draw the signal flow graph. All of you draw the signal flow graph. Come on, draw the signal flow graph. How many input nodes? 3 input nodes. What are that? Y1, Y2, Y3. So 3 input nodes. That is Y1 is the input node, Y2 is the input node, and Y3 is the input node. What is the output node? Y4. Y4 is the output node. So the branch start at Y1, end at Y4. Start at Y1, end at Y4. What is the path gain? 2. Next, start at Y2, end at Y4. What is the path gain? 4. Next, start at Y3, end at Y4. What is the path gain? 6. The path gain is 6. 2, 4, 6. So this is the signal flow graph. This is output node. These are input nodes. This represents the additional rule. Additional rule means this node is act as a adder or summer. Y4 equal to 2Y1 plus 4Y2 plus 6Y3. This is called additional rule. Additional rule. Many to one represents the additional rule. Many to one represents the additional rule. Many nodes to single node represents the additional rule. Okay. One more problem. Last one for today. Y2 equal to 5Y1. Y3 equal to 10Y1. Y4 equal to 20Y1. Draw the signal flow graph. How many input nodes here? Only one. How many output nodes? 3. Only one input node. Y1 is input node. Output nodes are Y2, Y3, and Y4. Output nodes are Y2, Y3, Y4. The branch start at Y1, end at where? Y2. What is the path gain? 5. The branch start at Y1, end at Y3. What is the path gain? 10. Next start at Y1, end at where? Y4. Y4. What is the path gain? 20. So this represents the what? Transmission rule. This represents the transmission rule. Transmission rule represents the one to many. One to many. Transmission rule represents the one to many. One to many. Okay. So I'll close here. You can, if you have any doubt, you can ask. Okay. Venkatesh.
Sir, in first page.
Tell.
Sir, if we interchange the feedback signals of a summing point and takeoff point, we get multiplication, sir.
No. Never interchange is a summing and takeoff. If interchange, additional summing point you have to consider. In
Not like
reduction
that,
rule, I
sir.
told na last day class. That
If
is a
we
last
change-
priority.
Okay, sir. If we change that summing point to another side, we get multiplication, sir, for feedback.
It's a summing point. Multiplication. How can you say what you are doing? You tell. You count the number of blocks. That's all. Before shifting number of blocks, after shifting number of blocks. Except for interchanging summing and takeoff. Don't interchange summing and takeoff. The remain all the cases, just count the number of blocks along the path. Hello?
Okay, sir. Okay, sir. Sir,
Huh?
if
Ah,
we
sir.
change the summing, okay. We can't.
Which is summing point,
Okay, sir.
man. Summing you are telling. Which summing point? Tell.
G3.
Hello? Huh?
G3, sir. G3.
G3. This summing point.
Yes, sir.
Where you have to change? Head of G1.
H. Yes, sir.
Head of G1, if you change before shifting, how many blocks? 1 and 2 na? G3
Yes,
and
sir.
G2 na?
Yes,
Oh,
sir.
yes or no? 1 and 2. 2 blocks only na?
Yes, sir.
If I shift here, how many blocks tell? That means this one will come to here. Now how many blocks count? 1, 2, 3. Yes or no?
Yes, sir.
Ante 1 block extra na?
Yes, sir.
G1 extra ante G3 by G1 you will get.
Okay, sir.
Okay na?
Okay, sir.
Next. Sri Charan.
Hello, sir.
Tell.
Sir, here G3 is seeing H1, no, sir.
G3
Is seeing H1.
seeing.
Means it is seeing three blocks, no, sir. And means if we change the first summing point, we should multiply G3 to H1, no, sir.
Why you multiply G3 H1? How can you multiply, man? It is not in series. Is it in series?
No, sir. Okay.
Then how can you multiply?
We should multiply only if they are in series, sir.
That's all.
Okay. Okay, sir.
Next. Abdul.
హలో సార్
Tell.
లాస్ట్ బిఫోర్ ఇప్పుడు చెప్పారు కదా ప్రాబ్లం ఉంది ఒకటి
ఇదా
సిగ్నోగ్రాఫర్
ఇదా
ముందు బ్యాక్
ఆ
ఇది సార్ ఇప్పుడు ఇది ఆల్జిబ్రిక్ అంటే అన్ని ఏ ఈక్వేషన్ తీసుకొచ్చా సార్ అంటే పెద్ద
ఇది ఆల్జిబ్రాయికే కదా, ఇది ఏందా ఇది లీనియర్ ఆల్జిబ్రాయిక్ ఈక్వేషన్.
నాలెడ్జ్ తీసుకోలేము కదా సార్ ఇందులో.
నాన్ లీనియర్ తీసుకోలేం, ఓన్లీ
అంటే
లీనియర్.
ఉట్టి మనం ఈ డైరెక్షన్ ప్రకారంగా మనం డినోట్ చేయాలి అంతే కదా సార్.
అంతే అంతే అంతే.
మెనీ టు మెనీ కూడా వస్తుంది కదా సార్ ఇది. మెనీ టు మెనీ అంటే ఒక నుంచి
we can consider many to many. Multi input multi output signal flow graphs is there na.
చేయొచ్చా సార్.
It will come, you can do. Okay,
అంటే డిఫరెంట్ y4 కి y
మల్టిపుల్ ఇన్పుట్స్ మల్టిపుల్ అవుట్పుట్స్ ఉండొచ్చు, ప్రాబ్లం ఏం లేదు.
ఓకే ఓకే సార్.
ఓకే, నెక్స్ట్
అర్థమైంది.
నెక్స్ట్ కార్తికేయ.
Yes, sir. I have a doubt in a question. Sir, not a sir. A question. I have a doubt.
Tell.
Sir, input RS, then G1S, then a disturbance is added after G1, and then G2, and then a negative feedback. Unity. So they ask how can the steady state error produced?
That will come later. Actually, it is volume 1 question. No, volume 1, no, volume 2, it is there. It will come.
Yes, sir. Yes, sir. Yes.
That will be actually time domain analysis. That will come later. Okay.
Sir, but it is in the basics of control system. So that's
by mistake they printed there.
Okay, sir.
It will come. No need to worry.
Okay.
We'll discuss that question in the class.
Thank you, sir.
Okay. Naveen.
In 1F, sir. Sir, in 1F page.
Tell man.
1F page, sir.
1F only it is.
Sir, here we can adjust.
Voice not clear.
Here in just and take a point.
Huh?
Sir, here we can adjust.
No. Voice not clear, man. Check it. Check your connections. Voice not clear.
Hello, sir. Now it's clear.
Now clear. Tell.
Sir, here beside RS takeoff point and summing point there, no, sir. We can adjust that too, and we can proceed,
Summing
no,
takeoff
sir.
never interchange. Summing takeoff interchange means we have to consider additional summing point. Never interchange the summing and takeoff. Okay.
Sir, you told in rules, you told, no, sir.
That is the last priority. If it is not
Yes,
possible
sir.
above all the rules, then only have to interchange.
Okay, sir.
Okay, now.
Sir, in 5F, sir. 5F. Sir, second case there, no, sir. C3 by R3. That one little bit confusing, sir.
What is the forward path again? Input R3.
Yes, sir.
This forward path na?
Yes, sir.
H2 minus 1 G1 G2. Return G1 G2 H2.
Okay.
This is the feedback path.
Feedback past minus will.
So 1 because here plus is there, here minus.
Okay, sir.
This numerator term as it is.
Okay. Okay, sir.
Okay.
Sir, yesterday you told one statement, sir, in comparison between open loop system and closed loop system. Sir, in that for a open loop system, you told it output cannot be measured like that. You told.
Open loop, you don't measure. It is not essential to measure. No need to measure.
But in closed loop system, we can measure output.
The purpose of sensor itself measuring.
Okay, sir.
Okay.
Okay, sir. Thank you.
Next, Krishna Vamshidhar.
Hello, sir.
Tell.
Sir, 6F, sir.
Tell.
Sir, if here gains are different, like
then you have to go by signal flow graph analysis, or otherwise you have to interchange summing and takeoff.
Like
that will become more complicated.
There will be one more summing point now, sir.
One more additional summing points will come.
Where to put that point, sir? Like
that we don't require for objective. IS conventional we used to discuss.
Okay,
That
sir.
rule I didn't discuss for problems, na. I didn't
Yes, sir.
solve.
That's right.
Not
And
required. Okay.
and there is one more volume on question, sir.
Volume 1 tomorrow I'll discuss.
Okay, sir.
Volume 1, volume 2 both I'll discuss. Okay.
Okay, sir. Thank you, sir.
Next, Nikhil.
Hello, sir.
Tell ma.
Sir, you talked about volume 1 and volume 2, but I didn't get that it.
Did you ask them?
Where,
They'll
sir?
send to you, na? I think.
Where?
I think you have to purchase, I think.
I purchased, sir, but they didn't give me it. How other student get?
Postal only, through postal. You have contact number, na? Office contact number?
Yes, I have.
You call them and ask. I
Okay,
paid
okay.
the amount, but I didn't receive it. So please send the booklets. When you joined?
27th September, I think.
Well, this many days, what you did, man? 1 month over. Remain booklets, you got it.
Yes, but not the control systems.
Remain books, you got it.
Yes.
Ask them. You call them and ask, na?
Yes, okay, sir.
Okay. Akansh Shalal.
Hello.
Atal.
Sir, what's the meaning of perturbation? Perturbation. Sir, it's
Perturbation
written.
means variation.
Okay. Okay, sir. Okay, tomorrow you will discuss this.
Tomorrow I'll discuss it. No need.
Okay. And sir, volume 1 is the textbook and volume 2 is the practice book, right?
Volume 2 is just practicing questions. That's all.
And volume 1, that textbook, whatever. it is
Textbook
given.
and I will have some questions.
Okay.
Actually, we have to solve the questions only volume 1 in the class. Volume 2 you have to practice.
Okay. And so the first class was very nice, but after that it's going very slow.
You are feeling slow.
Yes, sir. So
No,
first class.
there are some students not studied. That is the problem. Some students in the BTech, they didn't study.
Yes, sir, but we are preparing for February, right? So
It will cover it. No need to worry. I'll little bit.
because first day all the questions was very good. Means I was enjoying when the questions were.
Second day also I didn't decrease the speed. I think
I don't know.
second, third, fourth day. Today only little bit slow.
Okay.
Today only little bit slow. Okay.
Okay, sir. Thank you.
Okay. Are you able to understand, na?
Yes, sir. Yes, sir.
Okay. Solve all the problems. Okay.
Okay, sir. Sir, this type of question which it is showing on the screen, this you will do by when G1, G2 will be given. You will do.
Then you have to go by signal flow graph analysis.
Sir, you will make us do this type of question.
You go by signal flow graph, right? It will come in the next class. Signal flow graphs you will discuss, na?
Yes, sir.
Their block diagrams problems also will solve. What is there?
Sir, because here there are 4 forward paths.
Here 4 forward paths and 1 loop is there.
Yes, sir.
1 forward path G, second forward path G into H into G, third forward path again G, fourth one again G into H into G, and 1 loop 1 minus G square H square.
Sir, answer will come same because
same.
Okay.
Denominator you can write it 1 plus GH into 1 minus GH. Numerator take it common. Denominator numerator one term cancelled, then you will get the same answer.
Okay, sir, got it. Thanks.
Venkatesh.
Sir.
Tell.
Sir, yesterday you discussed block diagram techniques, no sir?
On.
Yes. Sir, can you repeat the rule number 5 and rule number 7, sir?
Again, I have to draw here. What is the rule number? Just you before shifting, you write the output.
Sir?
Before shifting, you check the output. What is the output? You got it.
Okay, sir. Adjusting block gain and takeoff points, sir.
Whatever it is, Amma. No. Right. See, R is there, here G1 is there, here G2 is there. This is the simple principle only, na? 1 by G3 you take. Here to here you shift it. For example, here what is the output? R G1. You shift here, what is the output? What is the output? Tell.
R G1, G2, G3, sir.
R
G1,
G1,
G2 by
G2
G3.
by G3. That's
G3.
all. But what is the answer you want? R G1 you want.
Yes, sir.
What you have to do? This should be cancelled, na?
Yes, sir.
And what I have to do? G3 by
G2.
That's all. So that this two will get the cancelled. Then you will get RG1.
Okay, sir.
The same principle you have to use it. Before shifting, after shifting, it should be same.
Okay, sir. Sir, then adjusting summing point and takeoff point, sir.
That is not required. No need to think about that. Because that we don't use, na?
Okay, sir.
Okay, na? That is not required. That we leave it. Okay. First of all, block diagram question, any block diagram question comes, is solved by signal flow graph analysis.
Okay, sir.
That will be the best way. Okay, na?
Okay,
Just
sir.
for idea sake, only block diagrams I discuss. But better follow signal flow graphs. Okay.
Okay, sir. Sir, can you explain the relation between bandwidth and feedback, sir? Once I didn't
Gain
understand.
bandwidth product constant, na?
Yes, sir.
Then what happened? Gain decrease, what happened? Bandwidth?
Increases, sir.
That's all. In feedback, gain will decrease, na?
Yes, sir.
Feed bandwidth increases.
Okay, sir.
Okay.
Okay, sir.
Okay, I'll close it. HTTP Forum, Autodesk, Comfort, T5, Sketchbook, Forum, Recovering, Unsaved File,